In a previous video, we talked about how to name ionic compounds, how to look at the formula, determine the charges of the ions, how they combine to form a neutral compound. And just as a quick summary, metals, of course, ionic compound, metals combining with nonmetals. In this first column, the metals only have one valence electron, so the metals will release that one valence electron to become a 1 plus ion. So things like lithium, sodium, and potassium. Lithium loses an electron to become Li+. Sodium loses an electron to become Na+. Potassium loses its one valence electron to become K+, when they combine with nonmetals. In the second column, you have things like magnesium. Second column, they have two valence electrons. When they form ionic compounds combining with nonmetals, they will lose both of those, so magnesium will become a 2 plus ion when it's in an ionic compound with a nonmetal. Same thing, calcium, 2 plus ion. And then one exception over here, we have aluminum, 3 valence electrons, so aluminum always forms 3 plus. These transition metals we look at later, they can form different charges. But in these two columns and aluminum, they always form the same charge. First column 1 plus, second column 2 plus, aluminum 3 plus, when they combine with nonmetals to form an ionic compound. The nonmetals, in this column, they have 7 valence electrons. All they do is add 1 to become -1. So fluorine is in that column, right? So they become 1 minus. When it combines with one of the metals to form an ionic compound. Chlorine, same thing, single minus. Bromine, same thing. Always, when they're in ionic compounds combining with metals, we'll add 1 electron to fill that valence shell and become 1 minus. Over here, the next one over, 2 minus. Oxygen has 6 valence electrons. It will add 2 to have a -2 charge. And then in this column over here, 3 minus. Nitrogen has 5 valence electrons. It will add 3 to fill its valence shell with 8. So we can predict the charges of these ions based on their position in the periodic table. So when we're preparing to do net ionic equations, it's helpful to say, okay, what happens when these ionic compounds dissolve in water? If I take sodium fluoride, what happens? The water molecules separate the ions out and they are moving independently within the water. What is sodium? It's in that first column, Na+, right? Fluorine, it's in that the column with 7 valence electrons, always F-. So what happens? The sodium ion will be in solution, separated from the fluorine, because the water molecules have taken this thing and dissolved it and ripped the ions apart from each other, and they're now surrounded by water in solution. And the fluorine ion, same thing, in solution with water. So the ions go from being connected in a solid to being separated and surrounded by water. If I have something like sodium oxide, and it dissolves in water, 2 sodiums, each of them Na+, oxygen's in that column where it has 6 valence electrons, 2 minus. So I dissolve this in water, what happens? The ions all separate out. I've got 2 ions, so one compound has 2 sodium ions that are now independent from each other, bounce around in the water, and then an oxygen. And so that is how we can show a chemical equation for sodium oxide dissolving in water. Let's do one more example before we start working with net ionic equations. Calcium chloride. Calcium's in the second column, right? Ca2+. 2 chlorines. Why? Because chlorine always forms Cl minus. Therefore, since compounds must be neutral, these ions combine to form a neutral compound, I need 2 chlorines, 2 minus for 2 plus. This dissolves in water. I get 1 calcium and 2 chlorines separate from each other in solution surrounded by water molecules. So now let's work with net ionic equations. So here's an example of a precipitation reaction where I mix 2 solutions. When I mix them, I see a solid form, right? 2 aqueous solutions. When I mix them together, allow them to react, a solid forms. Let's take a look at this one and say, what are the ions present that I'm mixing? CaCl2. Right, 1 calcium and 2 chlorines. Which this one, potassium has a single plus. And sulfur's right there below oxygen, always forms a 2 minus. So when I mix these 2 solutions, I get this kind of soup of all these ions together. So what is actually occurring? Well, the calcium ion and the sulfide ion, when they combine or when they collide, they stick together and form this solid, calcium sulfide. What about the potassium and the chlorine? They're still there in solution, right? I have K plus, Cl minus, potassium chloride. But since there were 2 for each reaction, I have that. So sometimes what we'll want to do in a chemical equation, if there's something like the potassium and the chlorine that are not actually part of the reaction, they're just there, while the calcium and the sulfide are doing their thing and forming this solid, what are the potassium and chloride doing? Nothing. So we call them spectators. They're not really part of the reaction. They're there in the solution. They have to be because these solutions have to be neutral, but they're actually not part of the reaction. They're not changing. They're aqueous ions in solution. They're still aqueous ions in solution. So frequently what we will do is let's remove the spectators. And just like math, I've got potassium, 2 of them, unchanged in solution. I take them out. Chlorine, unchanged in solution. I take them out. Now let's rewrite the equation without those spectators. Remember that when I'm showing ions by themselves now, so I'm not putting any charges up here, but now I'm showing just the calcium without the chlorine, I do need to show the charge, right, instead of just leaving it calcium. So calcium is 2 plus ion in solution, sulfur 2 minus in solution, and they combine to form calcium sulfide. And so we call that the net ionic equation, meaning what are the actual ions reacting, and we take out the spectators. Okay, let's practice one more and take a look at this one. A sodium carbonate. Remember this one, sodium again, always Na plus. What is CO3 here? It is our carbonate. 1 carbon and 3 oxygens have combined to form 2 minus. So that CO3 is 1 clump, that's 1 ion. And what do I have here? Strontium is in the same column there with magnesium, and etc. It's 2 plus. Bromine is single minus. They combine to form strontium carbonate. So go ahead, pause the video, and try completing this. Show the net ionic equation for this reaction. Okay, so I've shown the solution here. I finished here. Sodium bromide still in solution, so there are the ions there. What happened to the sodium? Nothing, completely unchanged. In solution here, still in solution, completely unchanged. What about the bromine? In solution here, still in solution. They are spectators, so I canceled them. So what's the true reaction? What's the net ionic equation for the reaction? Carbonate ions in solution and strontium ions in solution combine to form a solid. So these ions definitely are changing. They're going from aqueous to solid. So that is the actual reaction, forming a solid precipitate.